Hi Year 10s. This video I'm going to go through the last exercise 6F volumes of prisms and cylinders. So we're going to go through looking at the volume of a cylinder or prism, and it will also look at some composite shapes. We might give this oblique prisms a miss though, as really it's just a prism sort of on its side, and it's much the same skills. Just quickly, we're going to look at converting volume and have a look at going from like millimeters cubed to meters cubed and vice versa. We'll have a brief look at capacity, or if you get a question on capacity, I think the main thing is that 1 centimeter cubed is 1 milliliter. So therefore, I guess what we can say is 1 liter. 1 liter, milli means 1,000th. So 1,000 milliliters equals 1 liter. And of course, that also means that we've got 1,000 centimeters cubed is 1 liter. So whenever you get a question which looks at capacity, think about like a liquid or something. 1,000 centimeters cubed is a liter is also very useful. All right, and yeah, so look, let's just get straight into it. I'll try not to spend too long on this. First of all, when converting volume, you've got to consider that when we're looking at area, we're looking at only 2 dimensions. So I might have been looking at a square. So 1 square meter was 1 meter by 1 meter, and that would be 1 meter squared. But in this case, let's do 1 meter. Now, 1 meter cubed is a meter by 1 meter by a height of 1 meter. So this, of course, is this, and it's how much space it takes up. So that 1 meter cubed is all that space in there. Okay, so that's 1 meter cubed. Now, of course, how do we do a conversion without using the table up here? So we sort of know, okay, well, look, if I want to get to meters cubed, and in this case, we're going to do millimeters cubed, then it says, okay, well, I've got to multiply by 100 cubed and then multiply by 10 cubed, all right, which is an incredibly big number. But let's have a look and see how we can do it without that conversion table. All right, so I'm going to draw exactly the same cube, but this time I'm going to do it in millimeters. And of course, 1,000 millimeters is a meter. Okay, so we've got 1,000 millimeters there, 1,000 millimeters there. And of course, that's 1,000 millimeters. So if you can see, if I was to do the volume of that shape, then that's going to be equal to 1,000 millimeters times 1,000 millimeters times 1,000 millimeters. Now, we could even try do that in scientific notation because they're extremely big numbers. Okay, when we multiply them together, 1,000 is the same as 10 to the power of 3 millimeters. Let's do that. Times 10 to the power of 3 millimeters times 10 to the power of 3. Now, you might recall that when I have indices of the same base, that when we're multiplying them, we add the powers. So that's going to be 3 plus 3 plus 3 is 10 to the power of 9 millimeters, which is 9 zeros. Okay, or basically we've got 1 billion millimeters cubed. Okay, millimeter times a millimeter is millimeter squared times another millimeter is millimeter cubed. We've got 1 billion millimeters cubed is actually equal to a meter cubed. So it's very different when it comes to volume. So as you can see up here, that is the same as if I go from here to here. 100 cubed is 100 to the power of 3, and then we have to multiply it by 10 cubed. Now 100 cubed is 100 times 100 times 100, which is actually going to be 1 million. And then, of course, we're timesing that by 10 cubed, which is timesing that by 1,000. And 1 million times 1,000 is 1 billion. As you can see, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So as you can see, you can break it up into this, but we've already worked that out, haven't we? We've got here that we've got 10 to the power of 9 millimeters cubed in 1 meter cubed. All right, so that's just a useful thing to do if you're converting area. But feel free to use the table. All right, just quickly, so look, going through volume, you really just need to know that we want the consistent cross-sectional area times the height. Now, how do we get the consistent cross-sectional area? Well, first of all, I want you to pretend as though here's our shape here. If I was to cut it in this direction, like this, notice that I'm not going to have a consistent cross-section. In other words, if this was a piece of pie, the people out here getting this slice here, they're not going to be very happy because they've just got the ends of the circle. So we sort of can't do it that way. In actual fact, if I was to make this even, so everyone was to get a fair slice, then we'd have to go in this direction here. Now that direction there is our height, and our consistent cross-sectional area is just the area of a circle. So, so this thing here is the height, and this thing here is my area. So the volume is equal to the area times height. And as you can see, though, that it's not always the height is this distance here. The height could be turned on its side. We'll get through some of those sort of questions later. So let's have a look. The area of a circle is pi r squared. And of course the height is just the height. So that is the volume of a cylinder, and that's just an example of a prism. We've got a cylinder the volume is pi r squared times height. And of course, what about if I was to have a rectangular prism though? Well, a rectangular prism is different in that we can do this a number of ways. We could go ahead and we could cut it down this way, which means I'm working out this area, and this would be the height. Or likewise, I could get the same rectangle and I could go ahead and find the front face and do the same thing. I could find this and I could cut it down in this direction here. So we could also be that could be the height there. But it doesn't really matter because, of course, the area of a rectangle is length times width, and the height is just whatever the height is. So if you multiply those three things together, doesn't matter which way you do it, you're still going to get the volume. So finding the volume of a rectangular prism is really quite easy. All right, what we're going to do is go through a couple of examples. We're going to get rid of this one in your notes. Forget about that one. Let's go through and do this one. Find the volume of these solids. So we're going to do the volume is equal to. So I'm just going to think about this. Without sort of looking or being given a formula, I want to say, okay, well, that's the area. And then if I do the area, then I want to sort of cut it in this direction. And as you can see, that means that we're going to use that is the height. Okay, so the area of a rectangle, we'll do that front one. That one is 2 times 4. And then multiplying it by 3 is going to give me 24. And of course, our unit is meters cubed this time. And as you can see, it doesn't matter which way we do it. We could do 3 times 4 times 2. It's still going to give us the same result. Okay. So look, they're fairly straightforward. And the good thing about volume is when you've been doing total surface area, if I was to have a shape, and then I had a cylinder on the top, something like this, then you notice that we wouldn't usually count that sort of top thing if we were doing total surface area, but in this case, it's how much space it takes. So a half cylinder just takes up a half cylinder. We don't have to worry about surfaces. So these are a lot easier. Okay, so let's do this time. We're going to do this is a volume of a cylinder. We could go to the formula sheet, but hopefully you can recognize that that's the area times the height. The consistent cross-sectional area for the cylinder is only a circle, so that's pi r squared times the height, which is pi times 2 squared. Just make sure that you have the radius, not the diameter, times the height. And we could work this out in a calculator, but of course 2 squared is 4. 4 times 6 is 24 pi. Now that would be my exact value. You can work that out in the calculator. Just remember to, if you put it in the calculator, it's always going to give you the exact value if it can. So if I share that with you, if I've got pi times my radius squared, 2 squared, and then I times that by 6, it's just going to give you 24 pi. You need to go Control Enter, 75.39. Well, let's round that up. 75.40. Okay, 75.40 is our answer to 2 decimal places. And we are, once again, we're looking at centimetres, so it's going to be centimetres cubed. Now later we could sort of ask you, well, what would that be? If that was filled up with water, then how many litres is it? How many litres? So we can do some conversions, and remember that we have said that 1,000 centimetres cubed is equal to 1 litre. So if you think about it, if I was to think about how many litres that is, if I've got 75.40, so when you've got those questions, if I've got to get that into litres, then we'd need to divide by 1,000, which is the same as going back 3 decimal places. So 1, 2, 3, 0.75. 1, 2, 3, 0.0754 litres. So you might need to do some conversions, and please, when you have those conversions, I'll get you to have a look up here under here for those conversions. Okay, 1,000 centimetres cubed is a litre, being probably the most important one. All right, so now what we're going to do is we're going to just have a look at some composite shapes. And of course, this one involves, just remember, we want to find the volume of this entire shape. How much does it take up? Well, we've just got to break it up like we have before. So what we need to do is we need to go, okay, well, first of all, I've got the volume, and if you could do this if you wanted to, we've got the volume of a rectangular prism. We've got to find that, and then we've also got the volume of our cylinder. Now, if I add those together, then that is going to give me, well, let's do this one. First of all, it's the length, the area, length times the width, times the height. But of course, let's go straight to the area of a rectangle is length times width, and then of course we're going back and using the height. And of course, let's go ahead and do the area of a cylinder. Well, this is the cross-sectional area, so this is what the area would be. So it would be pi r squared, and then times the height. Now, just remember over here, it says here that these side lengths are 6 centimetres, so that means that the diameter there is 6 centimetres, and of course, it says that the height there is 2. All right, so let's go ahead and do that. We've got 2 times 6 is that front one, and we've also got that's times 6. All right, so we've got 2 by 6 by 6. Then let's fill in pi. Be careful, it's not 6 squared, it's half of 6 squared, which is 3 squared, and then we're multiplying that by the height, which is times 2. 6 sixes are 36, times 2 is 72, and of course we've got 9 times 2 is 18 pi. Now let's just do that. That's exact. having to pick up a calculator. Hopefully you can do the same, but you can put that in the calculator. And if you do that in the calculator, it'll give you 72 plus 18 pi. You'll need to get in decimal. So we've got 2 times 6 times 6 plus, when you could use brackets if you like, and then we've got pi times 3 squared times 3 squared times 2. 18 pi plus 72. So we want to get Control Enter. That's going to tell us 128.55 to 2 decimal places. 128.55. And that is going to be in centimeters cubed. All right, now look, give this one a go. I'll get you to pause this video really quickly. I'll give you, let's see if you can get this done in 3 minutes. So give yourself a few minutes. Can I get you to pause now and give this a go? All right, so hopefully you've had a bit of a go at this. When you're setting it up, make sure that you sort of try to do it in one line and break it up. We've got the volume of a rectangular prism, length times width times height. Doesn't matter which order you multiply them really. And then we've got the volume of a cylinder, full cylinder. So that's pi r squared. Be careful though, the radius is 4 and the height is 4. Okay, so we're sort of cutting it, we'll be cutting it in this direction. So that is this direction here is the height. If the cylinder was turned on its side, it's still the height, is what I'm trying to say, because if you did this, we're still doing this area. So yes, this distance here is still the height. Okay, a lot of people think that it has to be, you know, in this direction. It doesn't. Okay, so it could be, height could be this way, height could be this way. All right, so let's go work this out. I'm going to do this. You could do this in your calculator, but 8 times 8 is 64, times 3 is 192, and then we've got 16 times 4 is 64 pi, and of course you can work that out in your calculator to be 393.06 centimeters cubed. All right, so we've just looked at finding volume. It's easier, I think, than finding total surface area shapes, so hopefully you find this okay. Just remember the questions that involve capacity, liters, you'll need to do your conversions. So remember, 1,000 centimeters cubed is 1 litre, is very useful. Another thing is, we'll later on talk and look through some extended response questions, but for the time being, can I get you to have a go and get started on your questions from 6F, please? Give these a go. If you're finding them too easy, you can sort of try some of these later questions here. Look, a lot of them build up to this. Make sure that you try some conversions, which are in the earlier questions as well. All right, so, and hopefully from now, if there's anything left that you, in your actual practice test on page 18, you could also give that a go as well. We went through a little bit in class as well. All right, that's it for me. Thanks a lot, and yeah, be safe.